All right, what we want to look at today is that we want to look at trigonometric graphs. All right, so we want to look at graphs and trigonometry. Firstly, what we have to do is to quickly understand the shapes for y is equal to sine x. So y is equal to sine x will always take the shape of this form. It's going to start at the 0. It's going to go up, come down, and go back like this. So this is the shape, the general shape for y is equal to sine x. And you could see that this is a positive sine x. When it's a negative sine x, so when we have y is equal to negative sine x, the shape that we're looking for is a reflection in the x-axis. So what's going to happen is that we're going to start the same place at 0, but instead of going up, we're not going to go up. We're going to have to come down to its minimum, go up to its maximum, and then come back here. So that's the shape for y is equal to sine x and negative sine x. So the bottom line is we want to make sure that we have those shapes in mind when we want to do more things. For example, let's look at y is equal to cos x. Y is equal to cos x will not start at 0. All right, so we're talking about just having the general shape. So it's going to be like this. It's going to start up here, comes down, go back, and then ends there. So it's going to take on that shape, right? So y is equal to cos x will shape like this. That's the general shape. Let's look at what y is equal to negative cos x will be like. And it's going to be definitely a reflection in the x-axis, right? It's going to be that reflection in the x-axis. So instead of starting from the top here, it's going to start at the bottom. So it's going to go like that, come up, then come back down, and ends there. So we want to at least have that general idea of the sine positive, negative, cosine positive, and negative. So those are the general shapes. Now, what's the general format for these? So we're talking about y is equal to a sine, and in bracket, we'll have bx plus c plus d. And this is the general shape where the a, the b, the c, they have, and d, they have their particular meaning, where a refers to the amplitude. So a deals with the amplitude. And when we talk about the amplitude, we're talking about the maximum displacement from its rest position. So we're talking about it's a distance, all right? It's a distance. So it's just the maximum displacement from its rest position. What about b? It is said that the period, which is one complete cycle, is going to equal to 360 over b all the time. So b is going to tell us, right, how many times should we divide up that 360? Basically, how many times will we divide up that 360 to get one cycle? That's what b does, all right? So b helps us to find when we'll have one complete cycle, all right? So it will tell us that degree when we have one complete cycle. What is c? C will be our phase shift. And the phase shift is what we'll refer to as an horizontal shifting. So it's an horizontal shift where your graph would either move to the right or to the left. All right, so we're talking about our graph moving to the right or to the left, and we'll get into that shortly. D is our vertical shift. Our vertical shift. So then, this is gonna be talking about where our center line is. All right, so this link to our center line. It's gonna give us that center line. All right, whether we're gonna be at 0, a positive number, or a negative number. All right, so these are the key things that we'll be using to assist us as we go through. All right, let's start off with just a regular. So let us say we have y is equal to sine, say, 2x. So as you could see, there is no number here. And when there is no number there, definitely there's a 1 there, right? So our maximum and minimum will go at 1 and -1, which is, if you check on your calculators, ordinarily you won't get sine or cosine to go over 1 or -1, all right? So let's write down what we have. So we have our amplitude there is actually 1. Our B value is actually 2. We don't have C and we don't have D, so it's at 0. Those are 0. So I won't have any vertical or horizontal shape. So basically then, let's work out our period. Our period is going to equal to 360 degrees over 2, because my B is 2. So in this case, it's going to complete its cycle, one full revolution in 180 degrees. All right. So now let's look at this. Let's put up our graph quickly. So what we want to do though is there are 4 important spots, all right, that we have to always divide up our period in. So 180, we want to divide that into 4, and it's going to tell us exactly the different degrees for the specific places that we're going to be, we have some key points, whether it's the max or the min, or when it's crossing the x-axis. So when we divide this, we get 45. So it simply means that we'd actually have, let us say we have 45 here, then 90 here, then 135 here, and then 180 degrees here. These places are very crucial. So we are going to be getting our maximum, our minimum, and the x-intercept at these places. Bear in mind that we'll go as far as up to 1 and then as low as -1. So my maximum, so this is 0. My amplitude is 1. So from my rest position here, I'm going to go all the way up to +1 and as low as -1. All right. Remember the sine graph, the general shape, it's positive. So it's going to go up. We're going to go up at maximum at 45. Come back down at 90, crossing the x-axis there. Then it goes down 135 there, and then it comes back up right there. So that's the general shape. So we're talking about understanding that this here, our max, this here, our min, and here, that's our x-intercept, where those are 0. So that those 4 important places are very unique to these. So you can divide up this into 4 all the time, as long as you're dealing with cosine or sine. So that's for that. Let's look at another one. Let us say, let's change this up. What if we have y is equal to negative sine and maybe 3x? Again, my amplitude is 1. The fact that I do not see a number there, that's a -1, but an amplitude is actually a modulus. It's actually a distance. So a distance cannot be negative or positive, so it's going to be 1. My B value this time is 3. My C, 0, and my D, 0. So let's drop our graph. Or let us work out our period quickly. My period, when I'm going to have one complete cycle, is going to be 360 all the time over the B value. In this case, 360 divided by 3, and that is going to give us 120 degrees. I'll have a complete cycle in 120 degrees. The 4 important spots, the 4 critical degrees for this are as follows. 120 divided by 4, and we'll definitely get 30 degrees. So for every 30 degrees, I'm either going to be at max or minimum, or I'm crossing the x-axis. All right. So then I'd have 30 degrees. So this is 30, 60, 90, and 120. So we're going to complete this cycle in 120 degrees. But we want to understand that this is negative. So we're not going to go up. We're going to come down. And remember, this is 1. This is -1. So at my minimum, it's going to be here. And then, so basically, I'm going to start, come here at minimum, come here for crossing the x-axis. Then at 90, I'm at max. And then by the time I reach 120, I'm at 0. So let's do this. So it's going to be in this direction this time. And there it is. Because this is negative, we have to go in that direction. Sine x. All right, 2 sine x, and then we have plus 3. 2 sine x, and then we have plus 3. Now, as you could see, my amplitude is 2. So A is equal to 2. My B is 1. It's right there. B is the coefficient of the x. It's 1. We don't have a C. And D is definitely 3. This is going to be my center line. That is going to be my center line. So definitely, I won't be starting on the x-axis because this graph was vertically lifted up to +3. Let's draw our stuff. So ordinarily, I would right there. There is no horizontal shift, so I will be still dealing with right here. All right. However, we're going to be starting at 3. So let us consider this spot 3. This line is going to be my center line. And it is on this line that we're going to be dealing with. This is where the graph would have no shift vertically upward because of that 3 here. Now, from here, I'll go up to 5 because my maximum is equal to my D plus my A, and my minimum is equal to my D minus my A. So in other words, a 2, 3 should say plus 2 will give us 5 for my max. And a 3 minus 2 will give me a 1 for my minimum. 1. So if this is 0 and this is where my 1 is. So then if you want to really understand what's going to happen, the graph will stay within these boundaries. It's going to stay within these boundaries, just like that. So my graph was elevated to there. So sometimes what I do, I kind of put the degrees on this. So let's work on the degrees that we're going to be having. We could say that since B is 1, my period is equal to 360 over 1, which is a 360. So if I divide 360 into 4, I'll get 90 degrees for my spots. Those are my unique spots: 90, 180, 270, 360. So I'm going to finish here. But remember, though, that it's positive. So I'm still going to be starting on the y-axis. I'll be maximum at the 90, coming back 0 at the 80, minimum at the 270, and then 360. I'll finish. Here is my graph. Like that. Right? So we wanna understand that the motion, the movements of the graph, the movements, as you could see, is simply understanding, did we shift upward? Did we shift to the left or to the right? Let's try another one. So A is my amplitude 2. B is going to be 3, the coefficient of the x. D is going to be 1. So, and then C is equal to 0. So it means then I will be starting on the y-axis because I don't have a horizontal shifting. So let us see what goes on. Let's work out our period. My period is going to equal to 360 over B, which is going to be 360 over 3, and that will give us 120 degrees. Now, the unique spots, so if I say 120 divided by 4, I'll get 30 degrees for each spot of criticalness on the thing. So the critical spots are at 30 degrees apart from each other, starting from 0. My maximum is going to be D plus A, and that's going to definitely be 2 plus, no, 1 plus, let me fix it, 1 plus 2, same thing, but let me just put it in context. 1 plus 2, that's going to be 3, and my minimum is going to be 1 minus 2, and that's going to be negative 1. All right. So let us put up our spots. Let's draw this graph right now. So I'm going to take out 0. This is x. This is y. Remember, though, that there is a vertical shift. Use this broken line here. This is going to be my center line. And then my graph is definitely going to stay within these boundaries. It's going to go up to 3 at most, my max, and my minimum is going to come down to a negative 1. All right, so let us take a look at that. This is going to be 3, and this is going to be negative 1. I will be starting here. All right, but I will be starting on the y-axis, should say, because it's a cosine. You know, cosine starts at max or minimum depending on the shape. So let's put in our lines first. We'd have a 30 degrees somewhere here, 60 here, and then I'll have 1 here and a 120 right there. So I will be starting here at max, come down through the x-axis, and then I'm going to be at minimum at 60, going up across the x-axis at 90, and then a maximum back at 120. So that's going to be what my graph is going to be like. Let's go. All right, let me cut this better. I'll try. Let me try. All right, see with me. So basically, that's what we would have now to graph that. So remember, it is very important to understand the shape that we have, and then we work the shape accordingly. Or we could go up 4, all right? So let's write down what we have. Our amplitude is a positive number at all times. Remember, though, that your amplitude is a distance, and all distances are positive. B is equal to 2. C is 90, and D is 4. In order to work out where we're going to start, though, you have to equate this part to 0, the angle. So we're talking about 2x plus 90 is equal to 0. 2x is equal to negative 90. And x is equal to negative 45. So this is where we're going to start. We're going to start to the left of 0, negative 45. We'll get there soon. What's going to be my max? My max is going to be my D plus A, and that is going to be 4 plus 3 we're going to go up at 7. My minimum is going to be my D minus A, and that's going to be 4 minus 3, and that's going to be positive 1. All right. So then we're going to set this ship to sail. All right, that should do it for now. Remember also that we need to work out our period. So the period can be calculated by putting 360 degrees over the B value, which is 2. So the period is 180 degrees. So it's going to complete its cycle in 180 degrees. Remember though, we're not starting at 0. So we have to just, work this out. So if we divide this by 4, if you divide this 180 by 4, you'll get an idea of, oh, this is going to be 45. It's going to tell us how far they're apart, the specific points. There are 4 to complete the cycle. So let us say that this is negative 45. When you add 45 to that, you're at 0. When you add 45 to that, you're at positive 45. When you add 45 to that, you're at 90. And when you add 45 to that, you are at 135. So it is 180 degrees to move from negative 45 to 135 degrees. That's 180 degrees. So even though you don't see the 180 degrees, it's not about what you're seeing. It's about where it started and where it ends. All right, so let us now copy this. Remember that this is negative. So we're going to be starting like a reflection in the x-axis. So let's go for it. We're talking about the key spots now. We're going to be starting right here, right? Ordinarily. But remember that there is a vertical shift. 4. So then we're going to have to find where 4 is, right? So we're going to have to find our 4. So let's put on our 4 anywhere. All right, let's say we put 4 here. If I put 4 there, it simply means then that this 4 will be my center line. It's going to be the center line here. So technically, we're going to be starting here for 45, right there. And then the next at 0, I'm going to be here, because remember, we're going to have a shape like this. That's going to be the shape. So we're going to be coming down. So we're going for minimum. My minimum will be at the minimum, which is going to be 1. So let us put on a 1 anywhere here. Let's put on, so that's 4. Let's put 1 here. Let's put 1 there. All right, so that's a 1 right there. And let's put 7 somewhere up here. This is 7. So that's my 7. That's my 1. Let me put some lines there just to guide our thinking. So that's my 1 here. And my 7 here. So the graph is going to complete its cycle between this right now. So we're talking about coming down to 1. Yeah. Going up at 45 degrees, it's going to cross the axis again. And then by the time it reaches 90, it's at its max. And then by 135, it's back at 0. So this is going to be the shape we're working with. We're going like this. Down to 1, up, crossing the x-axis to the max, coming back down. So we're talking about understanding the shift. So you notice that we were not on the x-axis because it is shift to the left and then shift upwards. All right. So that's one that has everything in it. All right. I trust that you would understand and that this made sense to you. Thank you for watching Daily Maths Concepts. Look out for the next video that is coming.